So this is chemistry class, so we go inside our classroom and we start thinking about making experiments. Usually students are very excited because they think that it's dangerous just because it's chemistry, right? Wrong. Not everything that is dealing with chemistry has to be dangerous. Actually, in class, we prefer to be very, very safe. So you might be a little bit frustrated about it, but nevertheless, let's start making our chemistry class experiment. So I would like you to think of chemistry just like cooking, okay? So you just have some ingredients that you're mixing together, and at some point eventually, not necessarily, you might want to heat it. In this case, yes, because it's going to be cake and flour is not going to be raw. So you heat it up, and then all of a sudden you have this very beautiful and tasty cake. Is that for sure something that is going to happen? Well, not necessarily. It depends on how much amount of stuff you're putting. If you have too much liquid or too much solid, or the sugar is not there, I mean, your cake may be really off, so could end up in a kind of disaster. So you have to pay attention to the dosage and the ratios of your components, of your ingredients. So let's start with our paper, and let's start working. But probably not this paper. It's safer to have actually a notebook paper. So please make sure that you have paper and pencil, and you can start writing with me some reactions. So let's go to the board. You have this reaction that I wrote. So you have lead 2 nitrates, nitrate. Please don't forget how to name those compounds, obviously. So you have lead 2 nitrate, and you're putting it together with silver chloride to form lead 2 chloride and silver nitrate. So what is the very first thing you gotta do? You got to balance your reaction, right? So when you balance it up, you notice that you need to have a 2 in the silver chloride, so to have a 2 silver also with the nitrates, which makes perfectly sense actually, because you do have 2 nitrates here, so you do need the 2 nitrates here, and you have 2 silvers, and you got to have the 2 silver, and you also have 2 chlorines, which makes sense because now you have 2 chlorines as well. So your reaction is balanced. Why do you balance reaction? To make sure that you have conservation of mass. So conservation of mass is granted when you balance your chemical reaction. We are putting together our 100 grams. How much of the silver chloride I need in order for the reaction to be able to run? 1 lead nitrate that you have, lead 2 nitrate that you have, you need 2 moles of silver chloride. If you do not have those, you will not be able to run your reaction. So, but because I'm talking about how many grams I have and how many moles instead are written inside the reaction, then the very first thing to know is how many moles do we have inside 100 grams of silver or lead 2 nitrate. So in order for us to be able to do that, we need to calculate the molar mass. And the molar mass we calculated by using a notepad, right? A different sheet. And in here we see that you have lead nitrate, okay? But it's a lead 2 nitrate. So this means I have a plus 2 here, negative 1 there. So 2 times 1 is 2. 1 times 2 is 2, so those two charges are balanced. So the way I wrote the formula is right. And also I need to take into account how many lead I have. I have 1 lead, and the mass of the lead is 207.2. Then I have 2 nitrates, which means I have 2 nitrogen atoms and 6 oxygen atom. So 2 hydrogen and nitrogen and 6 oxygens. Okay, so put together I have a molar mass. So for this one I have 2 of those. Okay, 2 of those, and 6 of those. So now I have the lead, I have the 2 nitrogens, and the 6 oxygens. So the total mass is going to be 331.2 grams per moles. What do I do with that? Well, I can consider the ratio and saying that 1 mole, so this means per mole. So this mole has a 1 there. One mole is made of 331.2 grams. So now those grams go away, and I have the number of moles, which is your 100 divided by 331.2, which gives us a 0.30 moles of lead 2 nitrate. Now, if I have this many moles, basically now we have 0.30 moles lead 2 nitrate. How many moles of silver chloride would I need in order for us to make the reaction possible? So what do I do in order to move from the lead to the silver? Well, I got to multiply by 2. So this means I got to multiply by 2 this number also. So this means I will need a 0.60 moles of silver chloride. By doing so, I will make how many moles of lead 2 chloride? Well, the ratio is for every 1, the law says for every 1 lead nitrate, I'm making 1 lead chloride. So this means that if I have 0.3, I will make 0.3 moles, right? And instead, for every 1 mole of lead 2 nitrate, I will make 2 moles of silver nitrate, which means I will make 0.60 moles of silver nitrate. The point also is this 0.30 moles corresponded to 100 grams. So on the scale, I can now measure 0.60 moles. I got to measure grams. So how many grams of silver chloride would I need in order for the reaction to run, and in order also specifically to have 0.6 moles? So I need to know again, so let's go to the NDT and the paper there, and let's see that I have 1 silver, okay, because the moles is made, the 2 is taken care into the 0.60. So the mole that I need is 1 mole, not 2, is 1 mole of silver chloride. So the 1 mole is made of 1 silver and 1 chlorine. Silver 107.9 grams and chlorine is 35.5 grams. This means the silver chloride has a total mass of 143.4. 143.4 grams per mole of silver chloride. So this means that if I take the 0.60 moles, I do the ratio again, and I see again that every 1 mole have a weight of 143.4 grams. This is 1 mole. So this is going to be 86.0 grams of silver chloride that I need to run the reaction. How many grams are going to be produced with this lead chloride? So lead, we said, so lead was 207.2 plus the 2 chlorines, so twice 35.5 is going to be 71. Lead 2 chloride has a mass of 278.2 grams per mole, and instead silver nitrate has a mass of 169.9 grams per mole. So this means that for the lead chloride, we have moles, we have 0.30 moles, right? But 1 mole has this much weight. So this means that we are producing 278.2 times 0.3, and we have 83.46 grams. 83.46 grams. And also we have the silver blah blah. So we are made 0.60 moles, and 1 mole has this much weight. So this means that we have a 169.9 times 0.6 is going to be 101.9 grams. Now question, when we add 100 plus 1 plus 86, right? When we add those two together, we have 186, obviously, grams. So this is the total mass, okay, that we are starting with. When we put everything together, we have 0.36. So we are very close, considering all the rounding errors that we have done, okay, to conserve the mass. So now the question is, instead have, let's say, 250 grams of the lead nitrate, and I also scoop out, for example, 170 grams of silver chloride, how much would I really make? How much would I make in this situation? So the difference is that I am not using the grams to decide how many grams of silver chloride I need. Okay, I'm just scooping out the substances, and then, let's see what happens once we go for the reaction. So again, the law says for every 1 mole of lead to nitrate, I need 2 moles of silver chloride, and in that case, I will produce 1 mole of lead to chloride and 2 moles of silver nitrate. So what happens? So this one divided by 331.2 grams per moles, okay, will give us how many moles of lead to nitrate we have, and then so this one divided by 143.4 grams per moles will give us those moles as well. So 250 divided by 331.2 will be 0.75 moles of lead to nitrate, whereas 170 divided by 143.4 will give us a 1.19 moles of silver chloride. Now, how much lead to chloride are we going to be able to make? So basically, if we approach the problem as before, we can say that lead to nitrate and silver chloride will be able to make lead, and I'm not balancing yet, okay, and silver nitrate. So if I start with 1, I need 2 of the silver chloride. So if I start with 0.75 instead of the lead to nitrate, how much would I need for the silver chloride? Well, twice as much, because for every 1 I need 2. So for 0.75 I will need 150, right? So this one will be a 1.5, and then this one, instead, is the ratio is 1, so 2 is 1 to 1, so this is 0.75, and this is 1 to 2, so this is 1.5 as well. But this is considering only the lead and determining how much silver chloride we would need. But we have not done that. Instead, we have just scooped out of the bottle actually 1.19 moles. Right now 1.5, but 1.2 basically moles of silver chloride. So if we were following the same rule, saying, okay, let's not scoop out anything of the lead 2 nitrate yet, but let's use instead what I decided to measure first. So let's say that we are measuring first the 1.19 moles of silver chloride. In this case, how much of the lead 2 nitrate would I need? Well, to go from here to here, I'm going from 2 to 1, so I'm dividing by 2. So this means that 1.19 I got to divide it by 2, and I will have a 0.595 in this case, right? And if those are the rules, then I will have produced a 0.595 of the lead 2 chloride and a 1.19 of the silver nitrate. But now we have to decide, okay, which one is the right thing to follow? Do we follow how much lead we have scooped out? And what do we do with the silver instead? Or we use the silver, and what do we do with the lead? So let's analyze a little bit what's going on there. So this, the 0.75, is how much in reality we have. In that case, we would need 1.5 of the silver chloride. But let's look at the second reaction instead. The second reaction says, I really have 1.19. I do not have 1.5 of the silver chloride because I scooped out 170 grams, which reported to moles will be a 1.19. So this equation, the top equation, calls for 1.5. I do not have it. So let's see instead if I'm using the amount that I scooped out, which is the 1.19. This one calls for 0. Almost 6, which is great because actually I have scooped out more than what I needed. I have scooped out 0.75. So if I round this one as a 0.60, then I have 0.15 extra. So this means that I have an excess of the lead nitrate according to how much I have scooped out from the bottle. So this is too much, okay, because I can only use this reaction here, which means I'm only able to make 0.60, again if we round, of silver chloride. I will not be able to make 0.75 because I do not have enough material. I do not have enough chlorine, because to make 0.75, because I have the chlorine too, I need more than what I have. I need 1.5, but I have 1.2, 1.19 if I round. So this means that the chlorine is limiting me from making more products. Okay, so this one is the limiting reagent, whereas lead nitrate, this one instead is the excess reagent. Okay, so how much excess do I have? So we started, okay, with 0.75 moles of lead 2 nitrate. Okay, but we used only 0.595 moles. So this means that I have about 0.15. Okay, now this many moles, how many grams are those? Well, we consider those moles that we're talking about, right? And we are saying that we are talking about lead nitrate, which we know that 1 mole has a weight of 331.2 grams. So this means that I have wasted 48 grams of lead 2 nitrate. Okay, but I used completely this silver chloride. So this is all used up. Okay, but for the lead, I'm not using everything. I'm using only this with a leftover of this many moles.